My name is Austin Bingham, and that's my Twitter handle there. I work for and half own 60 North, a small consulting, application development, and training company up in Norway. We're all in the Oslo area as of about 2 months ago. And yeah, anchored metadata, oh, that's what I'm going to actually say as we go, is a field, I guess, some kind of an area that I kind of stumbled into backwards. In some sense, in no small part actually, because of some interactions here at ACCU, but as part of a larger tool. Right, so let's dig in. And is there a kind of rubbing noise or something? I hear something. Okay. So what's the problem? What am I talking about in the problem domain here? Associating metadata with code. All right, we've all run into this in one way, shape, or form, and there are ways of doing this, various different ways of doing this, some more useful in some situations and some less useful, and I think the area, the way I'm approaching it is maybe a bit different from how other people have tried to approach it, at least that I've seen in practice. So we've got a source file here. Does anybody recognize that language? It's Rust. Right, Rust is very cool, and then we'll talk a little bit more about Rust, but that's really beside the point. And we want to have data attached with bits of this code. I might want to say, do not mutate that during mutation testing for some reason. I might want to say, no linting on that. I know it's got a problem. Don't yell at me about it anymore. Or disable tests for this bit of code. And this is the nature of the kind of metadata I'm talking about, although it could be literally anything. It could have to do with code reviews. It could have to do with any kind of data you want. I'm not very picky about what kind of metadata we're talking about. But the idea is that I should be able to take an arbitrary range of code from some start to some stop and say, this metadata is associated with that, and I want to be able to retrieve that automatically. Okay? So this came out of work that I've spoken about here before, a tool that we write called Cosmic Ray. And Cosmic Ray is a mutation testing tool for Python. Mutation testing tools are typically language specific, and Cosmic Ray is one of the handful available for doing mutation testing on Python code. And you can get that there. I have talks about this. You can find it. It's interesting in its own right. It's fascinating in its own right. So it deserves a little bit of explanation. What is mutation testing? So it is a practice where you have your code under test and you have a test suite, right? And your test suite, if it's a full-powered test suite, is testing all the functionality in your code under test. I introduce a single change to my code under test, a very small change, perhaps changing a greater than to a less than or something along those lines, and then I run my tests. And in principle, if my tests are good, if my tests are perfect, the tests will fail now. They passed before the change, and now they fail because I have changed the functionality of my program, right? And ideally, all changes will result in test failures. And so if you have every change you make to the code results in a failure in your test suite, then your mutation testing has told you you have great tests. But you will almost invariably get some survivors, what we call them, the test suites that don't fail. And that shows you either a weakness in your test suite or perhaps extra code or sometimes more sophisticated things. Right, it's a really neat area, a lot of research that can go into it, a lot of kind of neat edges to explore, and it was doing this work that we came across the need for the anchored metadata. The primary reason we need to be able to communicate about our code in Cosmic Ray communicate about our code to Cosmic Ray is this notion, this problem of what are called equivalent mutants. So if you know Python, you don't have to know Python to appreciate this talk, but if you know Python in this case, you'll recognize this. This is the idiomatic main block. And it's saying, if my module is being run as the top level program, then do this, right? So Cosmic Ray says, oh, that's source code. I know what to do with source code. I change it, right? But of course, if this is being run in the test suite, this is not the main program. So this is code that is really important, but it's dead in some sense in your test suite, unless you jump through some hoops. So we want to be able to tell Cosmic Ray, please don't mutate that, okay? Another Interesting example from the Python standard, well, this is from the Python standard library documentation, and so it is by de facto idiomatic Python, is this code. It's not immediately clear what's problematic about this, why mutation testing would be problematic here, but it turns out to be really problematic because Cosmic Ray is going to see something like this 0 and say, oh, I'm going to change that to 1, I'm going to change that to -6, and I'm expecting your test suites to fail. But in reality, if this gets changed to any other positive number, and maybe even negative numbers, I haven't checked, everything will still work just fine. The only thing that will change is the amount of memory allocated to this double-ended queue here, this deck. And that's, okay, in principle you could test for that, but nobody is going to jump through the hoops necessary to do that, so we want to turn off mutation for that as well. So it's these kinds of things. We want to turn off mutation in very specific areas. In this case, really just right here. That's the only thing I really know I need to guard against right now. And back here, in this last slide, in principle, this could be a very complicated body of code, and I want to be able to just shut the whole thing down. So I need to be able to tag arbitrary ranges, not just lines of code. Right. So we identified this pretty early in the development of Cosmic Ray. You can see back in 2015, my smiling face says, in some cases we find surviving mutants are completely acceptable. We need to consider ways to allow users to add exceptions, by which I mean allow them to turn off Cosmic Ray, disable it for those parts of the code. And of course, kind of meditating on this problem, saying a reasonable approach is to let users provide exception lists of some sort. They would specify a line number or something, some notion of a range, but this would be brittle. I recognize this. Really, this would be kind of a brittle approach to have an external file saying don't mutate line 6. Then we would ignore those. Another more robust way would be to add exceptions in the code itself, but this also doesn't force people to pollute their code with exception notes. So we had this tension almost immediately of we don't want to, I didn't want to at least, force people to put stuff in their code to guide Cosmic Ray. There's already enough stuff being foisted on our code by linters and so forth. I thought it was a bit messy, inelegant, and not very cool to force people to put stuff in their code to guide Cosmic Ray. And one of Cosmic Ray's guiding principles has been that it will work on unmodified code. It still is a goal, and I think it still works that way. So we had this idea, wrote it down, didn't do anything about it for quite a while. So one option, an immediate option, one that I've talked about with people to some length, is this notion of these kind of, using comments to indicate what Cosmic Ray should do and should not do. And you could imagine, this no QA, this comes from some QA tool, a PyLint or something like that, saying just don't QA this line. We know it's garbage. Don't yell at me about it. And you could imagine, hash Cosmic Ray : some complex instructions saying don't run mutation operators, such and such at this range of characters. And we could make that work. We could embed it. And it has some nice qualities. It's easy to source control. It kind of follows the changes as they go. But again, I didn't like the idea kind of in principle. I wanted a cooler solution. So yeah, what's wrong with inline metadata? Well, one problem with it is it's language specific. And okay, I'm really only dealing with Python code in this case, but it's not a general solution. Externalized metadata, the kind of stuff that we're talking about for the rest of this talk, should be completely language agnostic. So it's kind of got that nice feature. You can have collisions. What if I don't want linting on that line and I don't want mutation? How do I make sure that Cosmic Ray's annotations and PyLint's annotations don't collide? I don't know the answer to that question, but I'm sure there's a way to do it. It's an engineering challenge, I suppose. It clutters the code. It's ugly. I don't like it. And it's not robust against refactorings. So you could imagine that I've got some tag in my code, and then I do a refactoring that fixes something about that tag, or about the code that tag was kind of guarding, and I don't remove the tag. So this kind of hangs around in the face of refactorings. And refactoring tools don't really understand these tags either. So if things get moved around a lot or things change shape as part of refactoring, some automated big refactoring, these might just be kind of spamming your code now, not doing the job they were supposed to do. So lots of reasons I don't like them. The big one really is I felt like they weren't very cool. So what's the solution? Obviously there's only kind of two ways to do this in a sense. You can put the annotations inline, or you can put them in an external file. Well, this is what this notion of externalized metadata is, or anchored metadata. So we have some external repository where our metadata lives, and it's somehow associated with the code. So this idea was spawned, as I mentioned, talk here at ACCU with two luminaries, Rob Smallshire, who's my business partner, and David McKeever, who is the mastermind behind Hypothesis, which was mentioned in the lightning talks yesterday. Both very smart guys, and we were talking about how to solve this problem. And of course, there was beer involved. I can't give them all the credit. We were, enjoying the after conference in a sense, and just kind of brainstorming ideas. And this led us down to thinking about, how could we make a system like this work? What are the possibilities? We talked and talked and talked, and that's probably where I came up with some of those notes that were in my Git repository's issue tracker. And it planted the seed, but it didn't plant the momentum. I didn't have time to work on it immediately. So we have them to thank, to some degree, for this idea. But the ultimate idea is, I'll have my source code here, I'll have my metadata off to the side, and I'll have some block, some bit of metadata that says, don't mutate this bit of code over here, right? Or disable a specific mutation operator on this body of code here. This is the fundamental thing we're aiming at. And can we make it happen? Yeah, you can probably make that happen pretty easily. But it has one big problem. You probably all identified it almost immediately, right? What happens when, not when, but as immediately the code is going to change. That's what code does, right? So we've got this, the Achilles heel, right? This is a very witty slide here, right? That this is the big problem, the actual problem we have to face when designing a system with externalized metadata. How do we make sure it can keep up with changes to the code? It's a hard problem, and I didn't know the solution to it. It's a very interesting problem. So it's kind of something that sat in the back of my mind for quite a while. It looks like it really hurts. That's a really big arrow. I don't know if arrows are really that big, but I suppose you'd want them to be pretty large. So this is the challenge that we faced. I faced. I did all this work. Take pride in that. Can we keep the metadata aligned with changing source code? We know it's going to change. Can we have some tool that doesn't involve the human all the time keeping the metadata lined up with the code? Well, I was able to ignore this problem for a long time because the issue tracker for Cosmic Ray is really big, and I was busy closing 212 other bugs. I wasn't in any big hurry to fix this problem, and it's not a commercial product. Our company doesn't depend on it. It's really a hobby, so I could ignore it for a long time, and I did. And Cosmic Ray became bigger and more complicated, more interesting, but this problem still kind of sat in the back of my head. I'd be on an airplane or something with some spare time, and I'd be able to doodle with it, but I never had a great solution. I never a ton of energy to put into it. And finally, for some reason, I got inspired. One evening, I was at home, and I said, I'm going to do some proper research and try to figure out what we can do about this problem. Has somebody else thought about it? And of course, I'm not that creative. Somebody else has thought about this before. In fact, they've kind of solved it. So these two people, Carol, anybody know how to pronounce that last name? Rostolchny, something like that, and Maria Bielakova, who I think she's the senior author with, she's got more publications and more citations. They wrote this interesting paper back in 2013, Metadata Anchoring for Source Code, Robust Location Descriptor Definition, Building and Interpreting. All right, that's a very tempting title. So I read that paper, and indeed, they had thought about exactly this problem. Right? You've got your source code, you want to annotate it somehow with stuff for an IDE or stuff for some analysis they're doing. I mean, they're software engineering researchers. They probably want to associate all sorts of data with source code. And they came up with a really neat solution. And it was not just neat, but it's something that I felt like I could fit in my head. It wasn't so technical and so expert level that I couldn't deal with it. And so this kind of got my attention, and it motivated me. And finally, I sat down to write a version of what they described. So the idea is actually pretty straightforward. Well, most of it's pretty straightforward. What they do is they have this notion of a context. And I've changed some of the terminology they used in their paper, but I call it a context. The context is not much more than a snapshot of the range of code that you want to tag. And that's what I call the topic. That's the stuff that you actually are tagging. So the context has the topic, and it has a bit of text from before and after the topic. So 10 characters, 100 characters, it's a variable you can choose. So that you have a snapshot of what it looked like at the time you were tagging it. And we're going to use that snapshot later on to realign the code. Coupled with that, this was the insight I never would have found. This is why they're much smarter than I am, is they knew about this algorithm, the Smith-Waterman alignment alignment algorithm, which comes from genomics research. It's for taking snippets of DNA, I guess, and seeing how they match up. And kind of does exactly what we need it to do. I can take the original context, the snapshot, and the change source code and see how the context aligns with the new code. So even if gaps are introduced or things are shifted around, this algorithm does the job of seeing how the context now maps to the modified code. And this was the secret sauce, in a sense. This is what I would never have kind of stumbled across on my own, so I was glad I found their paper. It seemed to solve the problem. So we set out to write this, and this is fundamentally the technique. Right? You create the context, and when you detect that the context is out of date, you create the anchor. When the anchor is out of context with the source code, you run this, and it will tell you, yes or no, I found a new alignment. And it can also tell you a bit about the quality of the alignment and so forth, so you can decide if you want to use it or force the user to come in and do new alignments for you. Okay, so we have, in principle, we have the science. Now we just need to engineer a solution. So the couple data structures involved. This is going to seem very, CS 101, data structures and algorithms. That's fine. I enjoyed those classes quite a bit, so this is what we get. The first data structure, of course, is what we call the context, and you already saw how that was shaped. It has the topic. That's just a string. It has an offset into the file. Offset is not as simple as it seems, and I think we'll talk about that maybe towards the end of this presentation. Maybe I can get some insight from some of you about this. You might know more about it than I do. But because of Unicode, offset is not terribly well defined. But it's, in principle, how far into the file does topic start. And then, of course, we have the strings before and after. So these comprise the context, along with a nominal width. And I say nominal because what we would like is for, if I made a context that was supposed to have 10 characters before and after, that's what I want in my before and after, 10 character strings. But of course, there may not be that many characters. So the context has to carry with it not only the before and after we were able to get, but how wide they should be in principle, so that when the context gets reconstructed after a change, we can make the properly sized before and after if necessary. So what do we have here? 5 pieces of data. That's what the context is. And this is kind of how it looks in Rust again. This is let me take a little sidestep here. In the description of this talk, I said that the tool we'll talk about is written in Python, and it was. And there still is a version of Python, but it has switched completely to Rust now. That's the primary implementation for various reasons, and we'll talk about that also as a sort of meta note at the end of this talk. So this is what the data structure looks like, more or less, in Rust. We've got the before, the topic, and the after. This is leaving out a few things. This is an older version of the data structure, but you see kind of how it's put together. We have those various elements. All right. Oh, wait. I explained this slide wrong. This is how the anchor maps onto the code in the context struct, right? So we have the topic here at some offset, and it has a before and after. So it's really straightforward stuff. There's no rocket science at this point yet. There's never any rocket science. There's just genetics research. Yes? Oh, it would, yeah, so this is an older version of the data structure. It used to be that we kept a number of lines of context, but now that's been changed to just a number of characters. Yeah, so yeah, sorry if this is. I realize this is a confusing slide after trying to present it for the first time. So I will fix that. But yeah, it was. His point is that this used to be after and before used to be a list of strings because we specified width as the number of lines to keep, but now we specify the number of characters, and they're just simple strings. Layered above context, we have the anchor itself. So this is just kind of a higher level structure, and it has an actual file path saying where is the file that I'm anchored to, what is the encoding of that file, because we need to be able to read it and things like that. It has the context embedded in it, so it aggregates the context. And the context, of course, is what points into the file, and that's where we also keep the metadata. So the metadata right now can be any valid YAML structure. I chose YAML because the tools in Rust and Python are pretty good at handling it, and it seemed like a low-res way of getting data. It's kind of arbitrary data into this thing. We may find in the future that's a bad choice, and we'll change it, but for now, that's what we're using. So if anybody has any thoughts about that, please let me know. Anchor is also very simple. The data structures here are very straightforward. But that brings us to the interesting part, the part that I think everybody's going to kind of get a kick out of. I think this is really neat stuff, the algorithms that we use in the tool. So Smith-Waterman, this is an algorithm from genomics, which is convenient because it means I can reuse some of the graphics from my cosmic ray presentations, because cosmic ray has this whole mutation theme. So this is, if you've seen me talk about cosmic ray, you've seen this blue chromosome or whatever it is. It's for aligning nucleic acid sequences to see, because often they get mutated, of course, and so they're very close but different when you want to see kind of where do they line up. That's what this algorithm is designed to do. It finds all potentially optimal alignments. So you could have multiple alignments between two arbitrary strings. You can think of the context and the source as your two strings, and they get scored as part of this alignment, and this will find all of the equally highly scored optimal paths or alignments, I should say. I call them paths because of how the algorithm works. You have to supply it with a scoring function and a gap penalty function, and that's an area that I haven't explored much. These are knobs in the algorithm that I want to explore a bit more when I have time and deeper understanding, because I think they'll play an important function in using these techniques in industrial settings. And then the optimal alignments are found through a backtracking algorithm, and we'll see that in a second. So that's a very high-level description of how it works. But the basic idea is that for every pair of input elements, so I've got two strings, the context and the source code, I build a matrix, and I basically start filling in scores for how well the different pairs line up. And these are based not just on the similarity between the two elements, the two tokens, but also the maximum afferent score. So you'll see how we build it up at afferent, the input scores that have already been calculated. So it's a bit of a dynamic algorithm, if that's the right term, I forget. So you have a scoring function. So if you have if you're following an actual alignment through the two strings, you use a scoring function, and there's a gap penalty if the algorithm discovers a gap. And clicker, maximal scores represent equally optimal alignments. So at the end, you'll have this 2D matrix with a bunch of numbers in it, and you look for the highest numbers, and there might be a bunch that have the same value. And from there, you can backtrack through the scores and find the alignments, and that's how it works. Okay, that's a bunch of words. It's much easier to understand graphically, but I wanted to give you a sense of what you're getting into. So let's kind of see how that works. Let's take these two sequences, GACCG and GCCA, and see how they align. I mean, you can eyeball this and kind of get a real good sense of how it should align, right? The G is going to align with the G, and then the C's ought to align together, and so maybe there's a gap here, between here and this A, right? And okay. Ba-doom-ching, that's actually what happens. But let's see how the algorithm figures that out. So we start off with a scoring matrix like this. At the top, we've got GACCG and GCCA here. And you can see we kind of have this extra column and extra row here. And that's because we're going to initialize those to zeros. So now we've got the seed matrix. And from this, we start to apply the scoring algorithms and the gap penalty algorithms. And how does that look? Well, these are the basic rules. These are the I's and these are the J's down this way. And we're going to basically look, G and G. Well, okay, those are the same. So they're going to take S of I minus 1 to J minus 1. This is 0 here. And they're going to get that plus the scoring function. Let's just say the scoring function is 3 if A and B are the same and minus 3 otherwise. And so in this case, we get 3, right? That's the score it gets. You don't have to memorize this stuff. I want to give you a flavor of kind of how it works. Then we look at this G and this A. So an important point is that the score here depends on the scores up in this upper corner, those afferent scores I mentioned, plus the running of this little algorithm here. So to calculate how G and A align, well, its maximum score of its afferents here is 3, but it's a gap because it's not on the diagonal here, and so we get a gap penalty, so we subtract 2 from 3 and get 1, right? And we wash, rinse, repeat that, you end up with a matrix that looks like that. And we remember all of these back arrows. These indicate essentially where our highest afferent score was, where we got our score from, and from those, we calculate the backtracking. So if you look at this see pretty clearly that the maximum score is 7, and in fact, I think I highlight that. So we only have one maximum score here, but in principle, you could have any number of 7s in a larger matrix, or any number of 13s, or whatever the scores can get arbitrarily large. And from there, we just backtrack up until we run into a 0, all right? So if we look at that trace, that's exactly what we intuited when we tried to map these two, when we tried to align these two together. We see that G maps with G, and then this G and A, that's not a map, that's a gap because it doesn't go diagonally, so there's a gap here. And then we see, oh, the C now starts to align with C, and this C aligns with that C, and then that's where it stops. And so that's the alignment that we get. Now, if you just take that and you apply it to the characters in your source code, which is what the tool I've written does, that's how we're getting the alignments. I thought that was pretty clever, a pretty neat application of a totally separate domain to something that we do in software. And it was relatively straightforward to code, kind of fun to code, and I felt kind of smart having done it, so great. But that's the heart of the update methods for realigning code. So there's this somewhat higher level algorithm we follow called this is the anchor updating algorithm. So if we detect that our context is out of date with the source code has changed in such a way that our before, topic, and after tags no longer match what they say they should match in the code, we take the context. Where's my pointer? My pointer's disappeared. We take the context and align it with all of the new source code. We say, take the context, take all the source code, run that alignment algorithm, and see where the context fits best in the new code. It may not fit anywhere. Your source code, of course, could change in arbitrary ways, and it may just say, no, I can't find any matches. There's no good matches, or they're all too poor. You can set criteria for that. But assuming, okay, this is not good because now my pointer's not working and it can't forward the slides. Once I've got a new alignment, I take just the topic part of the context and I figure out its portion of the new alignment, and that becomes the new topic in the updated anchor. And then from that, I can then calculate the before and after elements, and I create a new context from the realigned topic, and that becomes the new anchor. And it works surprisingly well, given how naive I feel it's currently being implemented. I haven't, as I said, there's lots of knobs and bells and whistles that we can play with in this that I haven't really even remotely looked at, but it's surprisingly effective for the kinds of things that I've wanted to try to anchor so far, which was very, very give me a lot of confidence this is the kind of direction we can move in. That's why I thought it would be kind of neat to talk about it here at ACCU. So, implementation of this. There's a tool that we've been working on for a little while called Spor. So if you're Scandinavian, Spor is kind of track or tracking. So my idea was that, of course, our anchors kind of track along with changes in the code. The initial version is this Python version here, and it still works, but I haven't done any real work to it in a while, but it still functions. So you can get that if you want to play with Python, or if you want to play with Rust, you can go to the Rust repository here. I should probably fix the naming now that this is the more official version of it, but Rust Spor is the name of the GitHub repository. And just to make clear, I definitely welcome input. If people want to put some time into this, give me ideas, extend it, whatever. I love to get even just feedback on whether it works for you. We're doing okay. I'm not going to fill 90 minutes, by the way. There's just not enough material for that. Okay, so Spor needs, of course, a bit more. It's not just data structures and algorithms. It has to, kind of store stuff on the disk and so forth. So what we have here is a typical project structure, let's say. This is actually an invalid project structure for Rust, but you have your .spor directory. So Spor needs a place to store the metadata, and that's where it puts it. And that is just a directory containing a bunch of YAML files that are given UUIDs, these big hexadecimal names. Each of those YAML files contains something like this, saying, which file it anchors, what's the encoding of that file, what's the metadata for that file, plus the context. So here we see before is a string, it's at offset 173. This is the topic, and this is the after, and that's the nominal width of the before and after. Okay? I don't know why sometimes YAML uses quotes and sometimes it doesn't, but I I don't ask questions above my pay grade like that, but it's kind of weird. So it's a pretty simple structure. It's not nearly as remotely as complex as something like a .git directory. It's just a bunch of YAML files right now, and I don't think that it really has to get any more complicated than that for the near term. Oh, okay. Yeah, it's a good point. Yeah, okay. So there's a correlation. Yeah, if there's a backslash, it gets quotes. Okay, bonus points. Yeah, thanks. So I learned something new today. So Spore's command line is pretty straightforward. You can see it's kind of inspired by tools that are flavored like Git with sort of subcommands and so forth. You're going to initialize a repository. You're going to add anchors to it. You can list the anchors for a source file, get details about them, do diffs and status, and then the big one, update. Update is the one that says, things are out of alignment. Let's do the realignment. So with that in mind, what I wanted to do was a quick demo. And this is, they say break a leg to actors, so I'm hoping that having a picture of a train wreck actually prevents a train wreck. I'm fairly certain all of this stuff works. So let's bring up an IDE. I probably need to make that a bit bigger so that you can all see it. How's that font size for the back? It's okay? Okay. So let's adjust. I can just drive here. I don't have to stare at the screen. So just to orient you a bit, I'll bring back up here. So got this live demo directory. In the live demo directory, I've got this history directory, which contains snapshots of one of the source files from Spore, this anchor.rs. So it's just, I think it's about 10 or 13 snapshots of it, linearly over time from the Git repository. And what we're going to do is, take the first snapshot, create an anchor, see what that looks like, then take the second snapshot, see that things go out of date, and then run the update algorithm and show that indeed it lines back up. So hopefully when you see that, you will be amazed. So let us, I'm sorry, I keep breathing into this, and I'm sure it's very obnoxious to you guys. Let me get that farther down. I can stop breathing. I could try that too. So I'm going to copy the first version of Anchor into anchor.rs. Let me make sure there's no Spore directory. Yeah. So in Rust, I could execute the built binary automatically, but if you're playing by the rules, you use this tool called cargo, and I say cargo run, and that's going to run the Spore tool. And I'm going to pass command line arguments to it. So init. So cargo run init. And what does that give us? We see now we have this Spore directory, and that's empty right now. We'll change that soon. So if I look at, this is the anchor. This is the anchor.rs. I'm just going to anchor, I think, this code here. I've got my notes here telling me what's actually going to get anchored. So let's create an anchor. Currently, I have to echo in the YAML that I want to be the metadata. I need to think harder about how this actually works. So I'm going to echo an empty dictionary into cargo run add. We're going to anchor rs is the file we're going to add an anchor to at offset 46 for 20 characters with a 10-character window. So if I go up here and I put my cursor here, we'll see that that B is offset 46, if anybody can read that. So I'm going to go ahead and run that. And it just takes a little bit. And so wrong thing. Let's go ahead and bring up the anchor file. If I look in the Spore directory now, I see I've got this, auto-generated file with this big ugly name. And we can see its contents. Its file path is anchor rs. Okay, that's right. That's the file we just anchored. Its metadata is this empty dictionary, UTF-8 encoding. You can see that the topic here is that attribute on the struct, the before and its type, a vec of strings. And we can see it's got some before and some after and a width of 10. Okay, so we've created an anchor. That's great. There's a few other things you can kind of poke around. I can say cargo run, list anchor.rs, and it will tell me, oh yeah, you've got, the output's a bit ugly, but it's telling me, yeah, you've got this one anchor here for this file, and this is the metadata in it. So you can potentially have an arbitrary number of anchors for any given file with different kinds of metadata in them if you want. And I can do things like ask for the details of that. So I can just give it a prefix for the ID, and it will show me some details about what the anchor looks like. Okay, that's just kind of showing you the user interface. If you have ideas about how this user interface could be improved, please let me know. This is a kind of a project that I typically kind of do on an airplane or something like that, and so I'm kind of confined, and I'm not getting a lot of outside input on how it works, and so it kind of works the way my brain works, which is not always optimal for other users. So now let's do the big thing. Let's copy version 1 of anchor.rs over. So now we've modified anchor.rs, and you can see, I think I got some new use statements here, and I had, oops, I didn't mean to do that. Got some extra little doohickeys up here as well, but the basic structure of the struct, of the context struct, has remained the same. But if I put my cursor at offset 46 now, which is over in here somewhere, that is not even any text even remotely close to what we have in our anchor. So if I ask cargo, or if I ask spore status, it will tell me, you've now got one of your anchors is out of date. That's all it's going to tell me for now. I can ask it for a diff, although this is not always terribly useful, and this is a 6. It'll tell me, you used to have all this stuff with minuses, now you got all this stuff with pluses. It's a pretty straightforward diff algorithm. It could probably be made more sophisticated. Clearly, things have gotten out of whack. The anchor is just wrong. So if everything works the way I claim it works, please, God, work. When I run update, it's going to do all the Smith-Waterman stuff we talked about, do all this new alignment. It's going to update this file, and we're going to see that basically the offset changes. So let's go ahead and run that. Runs pretty quickly, and we can see now the offset is at 194. Okay, so that's the sales pitch right there, that Spore in principle can automatically detect that your anchor is out of date and then automatically realign it under most circumstances. And we can wash, rinse, repeat on that a little bit. So if let's see, we get some interesting changes that Spore still keeps up with. So if I copy history 02, and then I run. So we can see, not much has changed there. So cargo run update. And again, we ran the update, and now the offset's 201. If I copy over anchor 3, things changed once again. And of course, you can imagine that when I run update, it still does the right thing. And it's when we get to number 5. So bear with me here. We'll do change number 4. We do an update. Nothing surprising. Now, if I copy anchor 5 over, we get a pretty substantial change in the anchor codes. When I push return, see what happens in here. Right. So context changed pretty dramatically, right? It grew into the structure that I explained to you earlier and that I was quasi-called out on. Now it's got strings from before, topic, and after, and it's got a width of U64 and an offset of U64. And of course, Spore is going to tell us everything's out of date. And you might think, well, can it actually keep up with that? And in fact, of course, it can, or I wouldn't be doing this demo. So that's pretty neat. It went from being a vector of strings that was anchored to just before string. So the algorithm's clearly not stupid. I mean, it's not the smartest algorithm in the world, but it's kept up with a pretty substantial change. Now, it may be that it did that, but that's not actually what we wanted it to do because it doesn't know about the semantics of the language. But this anchor seems like a pretty straightforward anchor, one that makes sense in some real-world scenario, and Spore has managed to keep up with it through a set of iterations. And this is the idea. This is the goal that I'm aiming for, that I can automate most, if not all, of the maintenance of these anchors. So I'm glad things didn't crash. I think if I copy over number 10, that removed a bunch of pubs, but of course, Spore is very clever, and Spore figures it out. Yeah. So that's really about, I mean, that's not the end of the talk, but that's about it for the demo. That's the flow I'm imagining. Now, I'm not imagining users having to type that in. I really do imagine that we'll have tooling built around it. Your IDE will do this kind of stuff. We'll have some more automated systems. But as an engine for maintaining these kinds of things, I think we've proven a point. And this is kind of, yes? If I remove the white space from... I don't think so. From the algorithm's point of view, the spaces are just characters. It's not treating them any... It might be. It might. Yeah, if we stripped out the white space. In fact, okay. I mean, this is a point I had intended to get to at some point in the talk. If you read that paper I mentioned, they take a substantially more complex approach. They tokenize things into words. They take out all the white space effectively, and they do word level matching rather than character level matching. And that's something that we definitely should experiment with. I don't know if it's going to be better or worse, or something that should be optional for the user. So there is this whole scope of things to explore. My intuition with going on the character-based matching was that I wanted to be able to catch situations where I refactored some bad Python code that wasn't PEP 8 compliant and didn't have a lot of underscores, and now has a bunch of underscores, and I wanted the anchor to keep up with that kind of stuff. But maybe that's Python myopic. Maybe there are other reasons to do other things. But it's a very good point. These are all these kinds of knobs and levers that we can apply to thinking about this problem that make it interesting and a bit daunting as well. I don't know if I'll ever solve it. But yeah, there are many more ways we can think about this. And well, we'll get to slides about other stuff we should think about with this tool.
When you create a mark a new region,
Mm-hmm.
you set the width, give you the size before and after.
Yeah.
Could you, at the point where you create it, essentially test that against the rest of the file to see what degrees, how specific it matches when you're after? And so if there's a lot of stuff that repeats, you say, tag this, but there's 10 others that match.
Yeah.
Then you're in trouble when it moves.
Ye-
Could you adapt the size of the window?
Yeah.
Try and make it specific to the point where you create it?
Yeah, I think it's a really good idea. You're doing some statistical analysis of the anchor you just created and trying to create an optimal context for that specific anchor is probably a really good idea. Because we've all seen code that looks like just some kind of cut and paste marathon happened one day, and the whole thing looks like 100 repetitions of the same code, and that would be really problematic for the update algorithm. I can't even guarantee which, say there were 4 matches coming out of the algorithm, I don't think there's a guaranteed ordering to those, and you would just get the first one, whichever one that happened to be. So another area I want to explore with regards to the update algorithm is locality-based matching, saying, okay, I got 4 optimal matches, 4 optimal alignments, but one of them is closer to the original location than all the other ones, and so it gets a higher ranking. And maybe we could also bring in Levenstein distance in there and say, okay, yeah, they're all optimal matches, optimal Smith-Waterman matches, but one of them is way off on the Levenstein scale, and the other 3 are better matches, so we can discard one. And it could get really involved. But yeah, that would be a neat thing to try. Oh, yes, sorry. I can't see there in the bright light, so. Yeah. Yeah. Yeah, I mean, Python being one of them, so it's kind of a target language for me. Yeah, it would be, well, I would love to have infinite time to try all these things out. Hopefully the code is approachable enough to other people that you will feel emboldened to try these things out. I'm a naive at best Rust programmer. It's my first time to ever really use it, so I'm sure I'm doing things in an off way. So if you are a Rust programmer and you see my code and you have ideas, let me know. I would love to hear. I wish I'd been able to go to the Rust workshop earlier today. I think it's a fascinating language with a lot of really good ideas in it. And I would relish being better at it. I think it's got a real solid place in my future in some sense. Okay, so we've kind of been dancing around this topic, and okay, we're okay on time. Future work, what do I think needs to kind of happen, or what I think can happen to improve this? One is obviously IDE integration. As I said, I don't foresee people sitting there, doing manual execution of Spore. I imagine them being in code in this case, and having somehow a highlight come around the bit that's anchored when you're in spore mode, and it can, you can put your mouse over and it can tell you, oh yeah, this is what you see, and you can click the edit button and whatever. This is totally mocked up. This doesn't exist in any way, shape, or form, but you kind of get the idea. I think you'd be nice to be able to, click a button that says, show me the spore information and have this pop up. Okay, and be able to futz with it. I think there's a lot to be said for that. And integration for creating, I could highlight a range and say create anchor here or something along those lines. That would be, I think, critical to its adoption in some circumstances. For something like Cosmic Ray, which it's the kind of thing that only maybe is run infrequently, you could have an expert user who's off to the side using it. But if it starts getting a lot of traction in other toolings that are have higher kind of iteration rates or so forth, higher usage rates, I think we have to have really nice integration with various IDEs. This came up in a discussion with the developer of another mutation testing tool. He said that another Python mutation testing tool called Mutants, which is very nice. He said he gets a lot of traction out of just being able to mark entire directories as don't mutate, or don't run this specific operator. We have no support for that in Spore right now. I don't think it will be terribly difficult to add something like that. That would basically just have an anchor, which is of a different type, which is a directory anchor, and it would say apply this metadata to everything in this in such and such directory. I think it could be very useful, especially as kind of a first pass thing. There's often projects that have a kind of a whole sub-range of stuff that you're not interested in doing mutation testing on because it's not tested, for example. So you just want to be able to, in one fell swoop, say, ignore all of that. So that would be, this feels like an airplane project. I think I'll be flying somewhere someday and go, I can just bang this out. So hopefully that'll happen sometime soon. This I'm kind of still hand-wavy on, this integration with source control, because one obvious weakness with the current system is that if I rename a file, Spore just loses it completely. It has no idea what's going on. So it would be nice to somehow have a Git hook or something like that that says, oh, I see a move has happened. I'm going to go to your Spore repository and find all the anchors that are affected and update them correctly, basically change the file name. I don't think this would be too hard, but I know next to nothing about Git integration beyond what I've done with, like GitHub or something like that. So if anybody has any ideas about how this might work, I would love to hear it. I don't know that we could make this completely bulletproof. I imagine there's all sorts of situations where anchors could get out of whack that this won't help us with. And I guess another problem with something like using hooks is it doesn't really do anything until the commit. So maybe there's smarter ways to keep file system operations in sync with Spore. I'm not entirely sure. But it is a known issue, something that needs to be thought about by smart people. And there's so much more, as you guys have brought up. I would like to investigate. I've rolled my own Smith-Waterman algorithm. It was a lot of fun to write, but I know that there has been a lot of research and engineering into making really high-performance Smith-Waterman algorithms. There's hardware that runs this stuff. So in principle, well, definitely in practice, I shouldn't be writing my own. I should be stealing one from somebody else. So that's something I should look at. Alternative tokenization, this question that arose earlier, should we be ignoring white space and tokenizing on words or something along those lines, absolutely needs to be explored. I think it's an important thing to look at. Different scoring functions, the way scoring functions cause alignments to drift one way or the other, those should be looked at. This notion of function ensembles, I talked about, like scoring functions plus Levenstein plus, distance from initial anchor, that kind of stuff. We could find ways of just getting more robust alignments, more robust scoring. When I start thinking about this kind of stuff, I think that I need to start focusing maybe on like a plugin system where I could let people experiment very easily with their own, kind of drop-in replacement algorithms. And I've started to try to engineer that into Spore now by using Rust techniques for that kind of stuff. But I'm again a neophyte with Rust, so I'm probably going in, if not exactly the wrong direction, at least not exactly the right direction. I'm starting to get a sense that I need to store the history of anchors as well to help users, or perhaps help the algorithm, understand how it's evolved over time. I can't completely justify this in a concrete sense, but I think that knowing what the anchor looked like over time might help us do better alignments. Because sometimes code, is one way, it goes to some other way, and then it goes back to how it was before. and sometimes it kind of goes halfway back. And if we had some information about the nature of what is anchored and how it's changed over time, that might help us do better alignments. And I think that would be easy to store. Warnings about match qualities. If you have low quality scores, low quality alignments, the user should know about that. They could be getting, just barely squeaking by getting an alignment, but it's actually kind of garbagey, and they should be warned in some sense that they have a bad match. This is an interesting one, semantic anchors. Suppose that Spore understood what a struct was in Rust or in Python, or Python doesn't have structs, but various language things. And I could say, I want to anchor a class. I want to anchor this attribute. That could be very powerful, and almost certainly would result in better realignments, but it goes against one of my initial complaints about alternative metadata systems, which is that now Spore needs to know about languages, whereas currently it doesn't need to know about languages. So again, maybe we could have some plugin or extension mechanism where we say, oh, here's the Rust plugin for Spore, here's the the C++ plugin, so now Spore knows about classes, it knows about namespaces or whatever. I am personally not terribly motivated to do this, but maybe that's because I lack vision. I think it could be very powerful. I added this section today after talking with Russell. Russell is as excited about Rust as I am, I think, and so I thought it would be neat to try to get a little bit more Rust content into the into ACCU. I think it's an appropriate place for Rust, for us to talk about it does things differently from C++, but it has a lot of the same goals. It's a systems language, but it feels somehow, I want to say safer almost, a little bit more cuddly than C++. Well, I mean, you couldn't be less cuddly than C++. So it's slightly more user-friendly in some sense. It does some really neat things, and it seems to do them well. And it stole ideas from other languages, and it stole the right ones. It stole some ideas from kind of Haskell-y kind of functional languages, and with results and monads and stuff like that. So the primary reason I switched from Python to Rust was because of speed. Python is not the fastest language, typically speaking, and I write pretty good Python code, but there's just so much you can do with the language without dipping into a lower level. Python it has a remarkably slow startup time, and if you're using a command line based tool like Spore, startup time becomes pretty important. And so I was becoming more and more concerned that as I was doing lots of alignments on big files, that Python just wasn't going to be able to keep up. But Rust is, it's nice and low level. It's got really good support for concurrency and parallelization, if you want to mince words. So this was the main motivation. And in fact, in the last talk I was in, Kate's talk, I did some really rough timing stuff. So here is, let me make that a bit bigger. This is an update run with the Python version, and it ran in 0.744 seconds. That's not fast, and that's just for one file and one anchor. The equivalent operation with the Rust implementation was 15 times faster, something like that. This is 0.043 seconds. Substantially faster without me being really good at Rust, without me knowing much about optimizing it and so forth. So this was the key insight, right? That I can make things faster in Rust without a whole huge amount of effort and expertise. Right. So fine, it's fast. That's probably important from an engineering point of view. But more importantly, it was curiosity. I wanted to learn Rust. It's kind of a cool language, and it was a nice, tractable problem. I was talking with in my workshop with John Lakos, and he was learning some Python in my workshop, and he kind of does what I do when he's learning a new language. He takes some problem he's already done I think we all do this. He took some problem he's already done several times. In his case, it was blackjack, and he was coding that in Python to learn Python. So you've got a substantial domain in your head, and you write a program that you've written before. So it's kind of a large-scale kata. So this seemed like a good opportunity to dive into Rust, and I've been very, very happy that I decided to explore that path. It has a bit of a learning curve. I mean, obviously, it's got some different concepts. You can talk with Russell about he is back there, yeah, about the lifetime checker. So the Rust compiler does a lot of work to make sure that you don't have, that it knows how long things live and that you don't have two writable references to the same thing. It goes through great pains to help you do things correctly, but sometimes you are really wrestling with it. So Russell wrestling, I'll say that 10 times fast. He was wrestling with the checker. And there's other elements of the language. He just does things differently from other languages I've spent a lot of time with. So it took me some time to get up to speed with it, but it was very cool. Ultimately, a very, very positive experience. I've enjoyed working with it. It's got very nice tooling. That cargo tool I was showing you is nice and handy. It has good integration with VS Code. I'm sure that it works well with other IDEs. I know it works well with Emacs. That was one of the last things I did with Emacs. It's a nice, fast development cycle. It feels almost as fast as Python, not quite, but the kind of the iteration speed. It's got nice, fast execution that we saw there. It feels quite maintainable. I've had to take step back and come back to it a few times, and I've never felt like I was totally lost when I dove back into it. The static types and stuff like that, so you have a nice framework to kind of settle your mind on when you come back to it, and it feels quite robust. I trust this code. I trust it as much as I would trusted my C++ code when that's what I was doing for a living, and I felt pretty good about that code. Rust just has a lot of mechanisms that keep you safe, and I think that's one of its strong points. So, which one do I think Python is better than Rust or whatever? I mean, that's a silly question, obviously, but I think that Rust was a better answer for this particular problem, and I'm glad that I chose it. I think that's about it. Yeah. So, yeah, that's what I've got for slides. I'm happy to talk about this for another, half hour that we have left, or if anybody has ideas or thoughts, we can talk afterwards. It's an interesting problem, and I think that it will set a seed in certain kinds of people's minds, right? And so if you're one of those people and you want to talk about it, I think it's a great thing to nerd out about a little bit. And if you want to get involved in the development of it, I am wide open for that. Just come and talk to me. So thank you for attending.